Math, tech, thinking. We're switching on the mind. Math, tech, thinking. When numbers get refined. Welcome to Math, tech, thinking foundation. Tune in, lock in, build your motivation. Step by step, we shape imagination. Math, tech, thinking. Math, tech, thinking foundation.
Hello everyone and welcome back to our continuing journey into artificial neural network and machine learning. I am Dr. Mehar Chand. In our previous lecture, we explored the role and significance of artificial neural network. We discussed how ANN mimic the human brain, how neurons pass signals, how network learn pattern, and why artificial neural network has become the foundation of modern deep learning. Today, we will take the next essential step before any model, whether it is ANN, a decision tree, or a regression model, can learn. It must understand the data. And to understand data, we need to know three fundamental machine learning concepts. These are features, labels, and dataset. These are the building blocks of every machine learning model or the problem. Without them, no model can learn anything meaningful. So let's begin by breaking these concepts down in the simplest and most intuitive ways. First, we need to understand the features or the clues that describe data. First, let's talk about the feature. Features are the input variable that describe our data. If we are predicting house price, features may be include like home size, location, number of the bedrooms, age of the house. Okay, so think of the features as descriptive characteristic. They tell the model what each example looks like. If a model is like a student learning from a textbook, features are the sentence and diagrams that the student studies. So again, we have three major components. We need to understand the numerical feature in the data, discover categorical features and their use, explore text features in machine learning. So among all type of these, numerical features are the most straightforward. Numerical features represent measurable quantities such as age, height, temperature, salary. They allow mathematical and statistical analysis, which is why ML model rely heavily on numerical values. Numerical features come in two forms. One is a continuous feature, values that can take any number within a range, for example, height and temperature. So these can take any value. Second one we have is the discrete feature, countable values like number of the student, number of order, etc. These features appears in every domain, from healthcare to finance, from retail to manufacturing. And remember, proper pre-processing like scaling, normalization, or handling outliers greatly improves the model performance. Next we have is the discovering categorical features. Now let's discuss categorical features which represent groups, types or categories. For example, gender, vehicle type, product category, weather condition. So categorical features come in two forms. One is nominal, or we can say unordered. For example, we can take colors, name of the cities, fruit categories. And the second one we have is the ordinal or ordered category. In this we can take the example small, medium, large. Okay, and second one low, medium, high satisfaction level. So categorical features are extremely important in the classification and segmentation task. But there is the challenge. Machine cannot directly understand textual category. So one must convert them into the numbers using encoding techniques such as one hot encoding, label encoding, a target encoding, embedding in deep learning. When categorical features are processed correctly, they significantly improve model accuracy and stability. Next we have is the export text feature in the machine learning. Now we come to one of the most intelligent type of the feature, which is text feature. Text exists everywhere: email, chat, reviews, comment, articles, report, but raw text is unstructured and machine cannot understand it directly. So we have to convert the text into numerical representation called text features. This enables ML model to understand meaning, analyze the sentiment, detect spam, classify topics, power chatbot, run search engine or process medical notes. Okay, so text features are meaning, context, relationship between the words, long run dependencies, and this is one done through techniques like big of the words, TF-IDF, n-grams, word embedded, and deep contextual embedding. With these, machine can perform high-level tasks such as translation, summarization, and questioning answering. Understanding the labels is again very important to implement the model or to develop. So now we understand features, and let's talk about the labels. Labels are the target output, the answer the model must learn to predict. If features describe the input, labels describe the correct output. For example, spam or not spam, disease present or not, predict house price on the basis of the features, whether a customer will churn. So labels come in two forms. One is classification label, categories such as spam, not spam, fraud, not fraud, cat, dog, horse. Second we have is the regression label, continuous values such as house price, sales prediction, temperature number. Okay, labels guide the model's learning. They help the model measure error and improve through feedback. Without labels, prediction based learning becomes impossible. We have discussed the classification label and regression label both, and you can see in the diagram these are the examples. Now we are talking about the understanding the dataset. Okay, so a dataset is a collection of data used in the machine learning to train the model and make predictions. With the features and the labels understood, let's move to the dataset. A dataset is the collection of the examples used to train the machine learning model. Think of a dataset like a spreadsheet. Each row is a data example, each column is a feature, and one column is the label. Okay, a complete dataset allows the model to learn by comparing prediction and with the actual labels. Data set component contain features which are the input, labels which are output. This structure help machine learning model learn relationship between input and output. In machine learning, a dataset is composed of features and labels. Each data point is represented as a row where the features describe the input variable and the label indicates the output. This structure is essential for training model effectively and making accurate predictions. Now, split of the data is very important to train the model. Okay, so to avoid memorization and ensure real learning, dataset are split into three parts. One is the training set. Okay, the training set is used to train the model on the data, and second one we have is the validation, used to tune parameters and avoid overfitting. Last one we have is the testing set. Okay, used to check model performance on unseen data. This split is essential for building models that generalize well. Okay, Now we have how the features model and labels interact. In machine learning, features served as the input and for the model which will then predict labels based on learned pattern from a training dataset. So here we have the some real world examples to understand how features, labels and a dataset work together. Let's take the real world example on email spam classifier. So features might include a number of the link, certain keywords, sender, domain, email length, presence of attachment, and labels like spam or not spam dataset. Thousands of email, each labeled as spam or not spam. The model learns the pattern that differentiate from spam from the normal email. Over time, it improves it identify suspicious messages. Okay, so these are the some very simple example here. Now we need to understand data through the features. Let's summarize the role of the feature. Features are the described characteristic of the data. They determine what pattern the model can learn. Good features, accurate model. Different task requires a different type of the features. Features engineering and selection deeply influence performance. Features are the eye and ears of a machine learning model. Next we have is the defining prediction with the labels. Labels represent the final answer the model must learn. They supervise the learning process, training process. They guide error correction. They tell the model when it is right and when it is wrong. Without labels, supervised learning cannot exist. And combining example in the dataset. More variety, better learning. A single sample teaches the model very little, but when we combine many diverse examples, the model learns patterns that are general, robust, accurate. For example, if you train a spam model only on email from one company, it will fail on others. But when you combine emails from many sources, the model becomes intelligent and adaptable. This is why datasets are often large. They help the model understand wide variations. So to make more accurate any machine learning model, we need the large dataset. So as much we have the large dataset, we have more accurate results. If we have less data, then the model accuracy is less. More data, we have more accuracy. And in the final summary, we how everything connect. Let's connect everything. Features describe the input, labels define the output, dataset combine many examples, model learn relationship between features and labels. Training and validation ensure good generalization. This cycle form the core of the machine learning. And thank you for joining me in this lecture. In our upcoming sessions, we would be on these fundamental and dive deeper into the machine learning algorithm, how they learn and how to apply them effectively. Until then, keep learning, keep exploring, and see you in the next lecture. Thank you.
Math tech thinking, we're switching on the mind. Math tech thinking.